Yes, dear students. In last class, we have discussed variation of due to with height, variation of G with depth. We have discussed. Now we need to discuss variation of G with rotation of the Earth. Variation of G with variation of G with rotation of the Earth. We are going to discuss. For example, let us assume an Earth. Let me take like this. Now, what we are taking here means we are taking this is equatorial plane. This is what we are taking poles. So, with respect to poles, Earth is revolving with angular velocity omega. Let us take here. And we need to calculate the G value at a point P. So a lambda angle is nothing but altitude, which we have to consider. Altitude. Now, so what is the equation we're having means derivation is not required for this. Nowhere they'll ask you for boards. G dash equal to what will get it? G dash means nu G. G into minus omega square R cos square lambda. That is nothing but angle between these two. The point where you're finding that point and equatorial plane, which we have to tell. For example, at poles, if you want to check now, at poles, so what we get it here means lambda value is equal to what we get it generally 90. So this fellow will go here, right? This line will go here, angle will become 90. So cos 90 is almost 0, na? Since cos 90 is 0, G dash equals to G into minus omega square R cos square 90. Cos square 90 becomes 0, therefore G dash equals to how much will get it? G will get it here. At equators, if you want to check now, at equators, lambda equal to what will happen? 0. So G dash equals to G into minus omega square Re cos square 0. Cos 0 is nothing but 1. Cos square 0, how much will get it? Na? 1. Therefore, G dash equals to G minus omega square Re. Generally, how much will get this omega square Re value means omega square Re value generally omega square Re equal to how much will get means 0.034 meters per second square will get it. How I can tell Sn is same thing means by using dimensional formula, acceleration due to gravity, this complete term should be acceleration due to gravity only. And how can you calculate this omega square Re value means Re value, you know that 6,400 kilometers. Omega square, if you want to check now, 2 pi by t. 2 pi by t is nothing but time period of the Earth which it takes to revolve itself is nothing but time period of the Earth which you have to substitute. Of substituting those all the values 0.364, which will get it here. For sure, we have to remember this value to minimize the calculations. Now, what we are having means G dash equals to G minus omega square Re will get it here. So, where gravitation is poles, or poles is more or equators is more means this is G. This is G minus something is there. So, gravity at poles is greater than gravity at equators, which we have to remember. What is the difference between gravity at poles and the equators means this is nothing but G here. This is nothing but G minus omega square R, just send this below here. So, if I send here now, so gravity at poles is greater than what we written? Gravity at equators, which you can tell here. Now, what we are going to do here means G poles minus G equators equal to how much will get it? Omega square Re. So, G poles minus G equators difference is how much means 0.034, which you have to remember. So, sometimes for numericals directly we can use these results also. G poles minus G equators, if you want to check result now. So, omega square Re, which will get it here. And which is greater means G poles is greater compared to the G equators, which we can tell here. Now, let me discuss one numerical here. In the numerical, what they're asking means, so let me change the slide. In this question, what they're asking here means question they're asking like this, Nana. The angular velocity of the Earth, which has to rotate, which has to rotate rotate so that acceleration due to gravity on 60 degrees latitude becomes 0 is, in the bracket they mentioned that RE value must be given, means RE equal to 6,400 kilometers they mentioned, and G equal to how much mentioned, means 10 meters per second square, which they mentioned in the question data. Options they given like this. Option A, 2.5 into 10 raised to minus 3 rad per second. Option B, 5 into 10 raised to minus 3 rad per second. Option C, 10 into 10 raised to 1 rad per second. Option D they given 7.8 into 10 raised to minus 1 rad per second, which they given options like this. Now first what we need to check means, what is altitude equation, latitude equation we're having, means latitude equation we're having what, G dash equals to G minus omega square RE cos square 60. Cos square 60 should be equal to how much? 0. Means this value will become to 0. Omega cos square RE is how much? Cos square 60. Cos 60 nothing but 1 by 2. Cos square 60 nothing but 1 by 4 will get it now. 1 by 4. If I shuffle this negative sign, it will become positive. Therefore, G equal to what we can write it here? Omega square RE times the 1 by 4, which we can write it here. So, omega square, if I want to calculate here, no? Omega square equal to what we get it here? 4GE divided by RE, which will get it here. So, omega square equal to 4GE, 4 into 10 divided by RE. RE value is how much? 6,400 kilometers, 10 raised to 3. 4 1 ja, 4 16, because 16 4 ja, 64, right? So, 16 times will get cancelled. Here 1 0, here 1 0 will get cancelled. Here 1 0, here 1 0, 10 power 3 remains. Now, what will get it here? Omega square equal to what will get it? Na? Omega square equal to 1 by 16 into 10 raised to 4, which we got it here. So, omega square equal to that much, you got it, means omega equal to how much will get it? Sin omega square, that's it. And a root of 1 by 16 into 10 raised to 4. So, omega equal to what will get it here? 1 by 16 square root is how much? 4. 10 power 4 square root is how much? 10 raised to 2. So, what we get it here? Therefore, omega equal to what we can write here? 10 raised to 2 we can send to numerator. 10 raised to minus 2 will get it. 10 raised to minus 2. 1 by 4 value, how much will get it? 0.25 rad per second SI unit. So, how can you write this thing? Omega equal to 2.5 into 10 raised to minus 3 rad per second, which we can calculate here. Listen once again, G dash equals to G minus omega square RG we are having. Cos square 60. In the question they mentioned angle is 60. No? 60. Cos 60 is 1 by 2. Cos square 60 is 1 by 4. So if I send this G here, no, minus minus will get cancelled. G omega square RE equals to 1 by 4. Omega square equals to 4 GE by RE. Omega square equals to 4 into 10. So on. So if we substitute, no, 64, 4 1, 4 16, they will get cancelled. This 0 will get cancelled. This 0, 10 power 4 it will become. Square root of 16 is how much? 4, and this is 10 raised to 2. If 10 raised to comes to numerator, 10 raised to minus 2, 0.25, 1 by 4 value. So that I'm shifting 1 0 here. So that's why my power is increasing, negative power. 2.5 into 10 raised to minus 3 rad per second. So if you observe answers now here, option 1 is correct for this question. For example question, if they ask you like this, what will happen here to answer me? Homework question, we can solve homework like this question. What they are telling means, suppose at equators, G dash equals to 0. Lambda value how much? It will become 0. Then you need to calculate omega value. Comment on omega. What is the answer of omega, which we need to comment? Next, we need to discuss about the orbital velocity. We need to discuss here. orbital velocity. So let me take Earth here, surrounded by Earth in an orbit. One satellite is revolving. Let me take here. That satellite mass is how much we're choosing, means small m. Earth mass is at center of the Earth is how much we're taking, capital ME we're taking here. And radius of the Earth is how much we're taking, capital RE. From the surface of the Earth to the satellite where it is, means at a height of h, let we take here. And this total length can be taken as small r. So I can write small r equal to capital RE plus h, we can write it here. And this orbital, this fellow is moving, means this fellow having velocity. How much tangential velocity you can take, means tangential velocity v0, that velocity which we need to calculate here. So according to Newton's law of gravitation, force between them is nothing but how much you can write, F equal to G M E divided by R square, we can write it. So that will act towards the masses, F value, Fg value. And outside what will act, centrifugal force act, how much is that, mv0 square by r will act. So that equal to what we can write, mv0 square divided by r will happen. So 1r will get cancelled here, 1m will get cancelled here. So what we can write it here, v0 square equal to what we can write here, gme divided by r, we can write it. Therefore v0 equal to what we can write, under root of gme divided by, in this place of smaller what we can substitute, capital RE plus h we can substitute. So capital RE plus h we can substitute here. This is nothing but escape velocity. So when RE value is almost equal to h value, when satellite is close to the Earth, no, h value will become small. When satellite is close to the Earth, means what will happen, means, so that value RE value is more big compared to the h value, means, so v0 equal to what we can do, that RE plus h value we can approximately to RE plus h value we can approximately equate to RE. So what we can write it here, means, therefore v0 equal to what we can write, under root gme divided by RE. So we learned already in last lecture, small g r square equal to what we can write, Nana, gme we can write it. So in the place of gme I'm going to substitute this value. So that equal to what we can write, under root of gre square divided by RE. 1 RE will get cancelled. That equal to what we get it here, under root gre we got it. Therefore v0 equal to what we got it, under root gre. For boards up to here we need to write for sure everything, we have to write up to here. 3 marks or 5 marks question they'll ask, it depends on boards. For the exam CBSE they'll ask you 3 marks. For example, it is for PU board, this way they can ask you for 5 marks, they'll ask you here. So we're having here gme divided by RE. G stands for what? That's 6.61 into 10 raised to minus 11. This is nothing but universal gravitational constant. ME value is nothing but how much mass of the Earth. RE value is nothing but radius of the Earth. If I calculate this value, how much it will come out to be? 64 into 10 raised to 6, you'll get it. 6 meter per second. This value. Or if you observe here, under root GRE, G value is how much? G value is nothing but how much will get it? 10. RE value 6400 into 10 raised to 3. So if you substitute those values, now how much this answer comes out to be? 8 kilometers per second. 8 kilometers per second, or 8 into 10 raised 3 meters per second also we can write it. So GME by RE value, how much will get it? 64 into 10 power 6. Or under root GRE value, how much will get it? 8 into 10 raised to 3 meters per second, which we have to remember for the solving numericals. So they're asking a question like this. A satellite is revolving around the Earth at a height of 7 RE from surface of the earth. Surface of the earth. Then its orbital velocity will be orbital velocity will be. See, in the question they're telling what, Nana? The given diagram. We need to make one diagram. So according to given data, we can make like this. So from here to here, RE, we know that. From here to here, how much they told you? 7 RE. And we know planet is revolving here with escape velocity, sorry, orbital velocity V0. So if you substitute this value in V0 equation, now what we are having V0 equation? V0 equal to, so H value is large now here. So you have to go with this formula. GME divided by RE plus H. So V0 equal to what we get it? GME divided by RE plus H value. RE plus H value, RE plus 7 RE. Therefore, V0 equal to under root of GME divided by RE plus 7 RE is nothing but 8 RE. Therefore, V0 equal to under root of 1 by 8 into GM by RE value we know. How much is that? GM by RE value 64 into 10 raised to 6 we know. So if I find this value, no, V0 equal to how much will get it? V0 equal to 8 into 10 raised to 3 divided by under root 8. So V0 equal to what we can write here? Root 8 into 10 raised to 3 meters per second we can write it. Otherwise, you can convert this root 8 into 2 root 2 also. 2 root 2 into 10 raised to 3 meters per second. For example, if answer is in terms of decimals, now V0 equal to 2 root 2. Root 2 value is 1.414 into 10 raised to 3. So 414. So meters per second we can write it. Therefore, V0 equal to 2.82 into 10 raised to 3 meters per second, which we can write in the answer. This is the answer for given question, which we can tell here. Yes, Nana. Next topic, what we need to discuss means we need to discuss what means about kinetic energy, kinetic, potential, and mechanical energy. We need to discuss. This is almost very important to the only for competitive. Rarely they will ask for PU and CBSE boards. So, for example, we are having this is the Earth surface. So, radius of the Earth is this much, let me take. And one satellite is revolving around this in this orbital, whose mass is nothing but m and whose orbital velocity is nothing but v0. So from here to here distance is so much, from here to here h, from here to here re. This total distance we can take in like smaller, which we can take here. So if you observe here, no, this is applicable for what? Only circular orbits. Only circular orbits. Fine. Now what we are choosing here means we are choosing v0 value. Just now we derived, no? v0 value, how much we derived? Under root of GMA divided by smaller we can write. Smaller is nothing but RE plus H. RE plus H we can write it here. And kinetic energy, if you want to calculate, no, K equal to what we know? Half mv square. So therefore, Ke can be written as what here? Half into m into this v0 square. V0 square value is how much? GME divided by RE. Therefore, kinetic energy can be written as G small m capital ME divided by 2RE, which we can write it here. And kinetic energy always positive. Why it cannot be negative means you can observe mass will never be negative here. If V0 value negative also, if you square that will become positive. That's why kinetic energy will never be negative. Next, what we need to discuss here, potential energy. So for example, if you have, this is nothing but small m, this is capital ME. This is nothing but capital ME. Distance between them, how much we choose is smaller. So how much is potential energy means we know that potential energy term U equals to what below? Minus G. So capital M is small m divided by what we are having? R we are having here. So this is nothing but potential energy which we know here. So if you want to calculate total energy, mechanical energy. So total energy can be written as what Nana here? Kinetic energy plus potential energy. So kinetic energy, how much we are having? G small m capital M E divided by 2RE, 2R Nana, plus minus is a direct will write minus GMME divided by RE we are having. So what we can take common here, if we take GMM by 2RE minus GMM by RE is there. If you subtract now, how much remains here? Therefore, E equal to what will get it here? Minus GME divided by 2R, which we can get here. This is nothing but total energy. See, if you observe here, no, kinetic energy equal to what we can write means magnitude of total energy. Observe these both are equal. Magnitude I'm taking. I don't want to take its negative sign. And that can be written as what means potential energy by 2, which we can write it here, Nana. Potential energy by 2. So this is when we are dealing with the magnitudes, we can directly answer some questions. So the same formula and same calculations we'll get in atom chapter also. Yes, they're related with the electron and proton. In the place of mass, they'll get electron charge and proton mass will get it. Same topic will get it there. For example, if they ask you as a fifth part, time period, if they ask you what we have to do. Time period. If they ask us time period, now what we have to do means, you know that V naught equal to what we know? V naught equal to displacement upon time. Circular, it is moving circular orbit, no? 2 pi r upon t. So t can be written as what? 2 pi r upon V naught. So V naught value we are having here. You need not to substitute this entire formula here while calculation solving. So V naught value already we got it from here. Now we can substitute from that value, we can substitute here and we can calculate that V naught value. Yes, next what we need to discuss means we need to discuss graphs here. So we learned that kinetic energy, how much we got it? Kinetic energy equal to GMME divided by R we got it. And total energy what we did? Minus GMEM divided by 2R we got it. And potential energy, how much we got it here? U equals to minus GMEM divided by R we got it. So what is the law we concluded here? K equal to magnitude of mechanical energy is equal to magnitude of potential energy by 2, which we got it here. So fine, if you observe here, no. So we need to plot the graph for the what? Energy versus R we need to plot. So let me take this is energy on y-axis. On x-axis I'm taking R. If you observe these three formulas, in this GMME by R minus, only positive one thing only is there, that is kinetic energy. And K is inversely, kinetic energy is inversely proportional to what, Nana? R. If X inversely proportional to Y, that follows which one? It follows rectangular hyperbola. So you'll get a graph like this, Nana. This is kinetic energy. If you observe here, two things again we are having. One total mechanical energy, one potential energy. So both are negative, so it will come below only. So no doubt in that. So there, which line represents what we have to understand? For example, you got two lines like this, two graphs like this, you got it. Now you need to represent what is potential energy, what is mechanical energy, you need to represent here. So how to represent that means minus GMEM by R, magnitude you check here, minus GMEM by 2R. So total energy is nothing but half of that one. Huh? So what will get it means here? This so down one will indicates what? Potential energy. This close to the origin indicates mechanical energy. This should be careful. For sure they will ask us. Again, this will be useful in next topic atom also, which you can tell here. So they're asking one question like this. What they're asking means, question says like this. Calculate V naught, second one, time period, third one, kinetic energy, fourth one, potential energy, fifth one, mechanical energy they're asking us to calculate. What is the diagram they given? Means they given one diagram like this, Nana. This is, we know, RE, radius of the Earth. So this is the given here. V naught having mass of 1000 kg, 1 ton, and where H equal to RE at a height of 6,400 kilometers. That's why revolving. So small r equal to what we are having, capital RE plus H. Na? So small r equal to RE plus H value is RE. Therefore, R equal to what we will get it? 2RE, which will get it here. So V naught we need to calculate first one. V naught equal to what we are having? Under root GM by small RE. Small RE value 2RE we are having here. You know that capital GM by RE value, you know that how much is that? 64 into 10 raised to 6. So therefore, V naught equal to what we can write means. So 64 into 10 raised to 6 whole root is how much? 8 into 10 raised to 3, which we discussed already. Divided by root 2 will get it here. So V naught equal to how much will get it here? V naught equal to 4 root 2 into 10 raised to 3 meters per second, which will get it here. That is nothing but V naught value, which you can calculate it. Second question, what are they asking? Time period. Time period, how much they are asking? T equal to 2 pi r divided by V naught we are having. So 2 pi r divided by V naught, if you calculate, no, T equal to 2 pi into small r value 2RE divided by 4 root 2 into V naught value. From here we are substituting. 10 raised to 3. 2 1 ja, 2 2 ja. These two will get cancelled. So what will get it here? Time period equal to pi by root 2 into, if it goes to numerator, 10 raised to minus 3 seconds will get it here. Seconds, RE is missing now. So RE, radius of that. So if you want to calculate those all values, now what you can substitute here? T equal to 64 pi into 10 raised to 5 into 10 raised to minus 3, 6,400 kilometers I substituted there, divided by root 2. So after substituting that, this value powers will get cancelled, 5 minus 5 and all. So what will get it means here? 64 pi divided by root 2 into 10 raised to 2 seconds we can calculate. We can substitute that pi value and root 2 value also. So we can solve the question. Next, what they're asking here as a part B is done. Part C, what they're asking here, kinetic energy they're asking here. So kinetic energy, if you want to solve here, no? Part C, kinetic energy. Kinetic energy equal to what you're having? GMEM divided by 2R we know here. So kinetic energy equal to what we can write here? GMEM divided by 2 into 2RE. Smaller value is nothing but capital 2RE. Na? So what we can write it here? Kinetic energy equal to, we can write like this. GME divided by RE, capital RE, into M by 4. So kinetic energy equal to what we can write, Nana, here. So this value how much you know? 64 into 10 raised to 6, you know, into M by 4, 1000 by 4. 4 1 ja, 4 16 ja. 10 raised to 6, 10 raised to 3. So what will get it? 10 raised to 9. Therefore, kinetic energy equal to how much you can write, Nana? Kinetic energy 16 into 10 raised to 9 joules, we can write it here. So let me write here as a part D. So part D, what we need to conclude here means kinetic energy, you know, potential energy you need to name. So total energy, let write. Kinetic energy equal to, you know, that magnitude of total energy, na? Total energy. So what we can write it here? So therefore total energy equal to what we can write? Minus 16 into 10 raised to 9 will get it. Total energy can be negative. Next, what we need to calculate? Next part, potential energy. So U equal to magnitude of U by 2. So therefore U equal to what we can write it here? Minus 2K. Therefore U equal to minus 2 into 16 by 32, no? Minus 32 into 10 raised to 9 joules we can write. So this is how, if you remember that law, no, we can minimize the calculation here. If you understand here, we need not to calculate. If you calculate kinetic energy, we concluded here, total energy we concluded, and potential energy also we concluded. That's how we can calculate here. Fine. Next, what we need to discuss? We need to discuss work done. Work done in moving object from surface of Earth to height h above the surface we need to calculate. For example, let me take the diagram like this. So first what they given means we're having Earth like this. Here total mass is there, center, and at this point what is there? Radius RE is there. At this point we are having mass M. Now I want to shift from here to here. From this point to this point I want to shift. This is mass. Here this is nothing but RE, this is nothing but H. So after shifting, this velocity is how much? 0. Before also velocity is how much? 0. So means kinetic energy how much? Means kinetic energy is 0, which you can consider here. So initial potential energy how much if you want to write means Uy equals to minus GMEM by R, right? GMEM by capital RE. Here what we can write it? U final equal to what we can write it? Minus GMEM by RE plus H. What is the question means? Earlier that object is here. That object is here earlier. Now they want to shift up to here. What is the work done required? They want to ask here. That's nothing but the gravitational potential energy. So we can tell that work done by agent is how much we can tell. Work done by agent can be written as U final minus U initial we can write because no part of kinetic energy. Velocity becomes 0. Velocity is initial 0. We consider. So U final minus U initial if you calculate here now. U final is minus GMEM divided by RE plus H we are having plus GMEM divided by RE. Why I written plus means minus of minus will become as plus we can write it. So RE we written here. So what we can take common? GME we can take common now. So work done can be written as, so if you take GME common no, GME if you take common no, 1 by RE minus 1 by RE plus H. Now we need to take LCM nana. Therefore work done equals to GMEM into RE plus H minus RE will go here na, minus RE divided by RE into RE plus H, which we got it here. So plus RE minus RE will get cancelled. So work done by agent can be written as what? GMEMH divided by RE into RE plus H, which we got it here. And we learned that small g equal to what we learned? GME by RE square, or GRE square can be written as what here? GME. So in the place of GME, you are going to substitute this value. So work done can be written as what here? GRE square small m into H divided by RE into RE plus H, which we are having. If you observe here carefully, one RE will get cancelled. So how much remains here? M is there, G is there, H is there. So and RE is there. So I'm writing like this. MGH into RE by RE plus H remains, which you can write it here. Now I would like to send this RE to denominator. So if you would like to send RE to denominator, what will happen here? Work done equal to MGH RE plus H divided by RE, which will get it if you send RE to denominator. So this RE will get cancelled. So work done equal to what will get it? MGH divided by 1 plus H by RE. This is the actual formula of work done to move an object from at a height H from the Earth's surface. So this one we got it. So basically these questions frequently asked in NEET and CET also they asked here. So what is the question NEET they ask what means? NEET 19 they ask one question here. What they ask means if H equal to RE, then calculate weight of the object. So or work done of the object to move from so on to surface to at a height RE. So work done by agent what we are having here? MGH divided by 1 plus H by RE, which we are having here. So that equal to what we can write it here? MGH, mg into REH value divided by 1 plus RE by RE. RE will get cancelled. Therefore, mg RE by 2 is the answer. In KSET 19 also they ask one question here. KSET 19. So if H equal to 3 RE, then find work done to move that they're asking. Just solve this question like homework. See, they're asking one question here. So what they're asking is, question says, calculate work done in shifting an object from Earth surface to height h equal to 7 RE in circular orbit. This is what they asked here. So initially, this is the Earth object is somewhere here, and this Earth mass is ME. We can take this is RE. Initial velocity is 0. So finally, they're shifting by external agency. So this is ME, this is RE. Somewhere they shifted in this orbit. From here to here, how much they told? H. This we can take a total, we can take like smaller. And now this orbit we shifted, this velocity is V0 they want. Is there here. So if you want to calculate total energy here, no? Total energy can be written as what here? E initial can be written as kinetic energy plus potential energy initial. Kinetic energy is 0. So E initial equal to potential energy na minus GME M divided by RE. Energy final we need to calculate na. Energy final equal to what we can write? Minus G M E divided by what we can write? 2R we can write it here. 2R. R value if you observe here, no, H is nothing but how much they given in the question? 7 RE. 7 RE plus RE nothing but 8 RE, na? Sorry, 8 RE. 8 into 2 will be how much? 16. Therefore, energy final equal to minus GME divided by 2 into 8 RE. So, E final equal to what we can write? Minus GMEM divided by 16 RE, we got it. So, work done by agency can be written as what? Work done by agents can be written as energy final minus energy initial we need to do. So energy final is how much? Minus GMEM divided by 16. Minus of minus will be plus. So minus of minus will be plus, na? Plus GMEM divided by RE. So if you substitute here, no, if you subtract here, no, what will get it? G RE is it, right? Yes. GMEM divided by RE, if I take common, no, 1 minus 1 by 16. If you take LCM, 16 minus 1 will be 15. Therefore, work done by agent will get like 15 by 16 into GMEM divided by RE, which we got it here. This is the answer for question as it is given in the option in one JEE question. It's fine. Now we are going to discuss about the escape velocity. We are going to discuss. Escape velocity or escape speed. So what is mean by escape speed means the minimum velocity given to an object such that it escape out of Earth's surface from gravitational field influence. Means it should not absorb gravitational field influence, means how far it has to go. So to go that much distance, how much speed we need to use, nothing but escape speed we need to discuss. So for example, let me take Earth Nana. Yes. Now we're having Earth here. Radius is how much? RE we are taking here. And where is the object? Object is here. This is RE. So we are projecting with what? Escape velocity VE, who is having mass M. So this is nothing but radius RE we know here. And object is going to where distance? Up to certain distance, very large distance. So after reaching that large distance, we are taking velocity is how much? 0. What is the large distance means? It's going very large distance compared to the RE. So we're considering like infinity. So what we need to do means we need to apply law of conservation of mechanical energy. We need to apply. So initially velocity is there, RE is there. Finally, what is there? Velocity becomes 0, RE will become infinity distance. So what we can write means here we can apply energy conservation. Total energy at 1 should be equal to total energy at 2. So what is 1? This is the point 1. And what is 2? This is the point 2. At 1 can be written as what? Kinetic energy at 1 plus potential energy at 1 should be equal to kinetic energy at 2 plus potential energy at 2 we can write now. So kinetic energy at 1 can be written as what? VE we given na? Half mVE square. Potential energy can be written as minus GMEM divided by RE. Observe here. This is nothing but what here? ME. MEM both are separate by a certain distance RE is equal to kinetic energy half mv square. After reaching infinite distance, velocity we consider as 0 square minus GMEM divided by RE plus infinity considered to be infinity. Anything upon infinity also 0. This also becomes 0. Means if I send this negative sign, it will goes to this side, it will become like positive sign. So what we can write it here? Half mve square is equal to GMEM divided by RE, we got it. Na? So what we need to calculate? Escape velocity only we need to calculate. Na? So send remaining things that side. So this small m let cancel. VE is equal to what we can write? 2 will go here now. 2 GME divided by RE, we got it. Square root of. This is the one escape velocity standard formula which you have to remember for solving the numericals. And you know that under root GME by RG value, you already know how much is that? 8 into 10 raised to 3. So VE can be written as what means? 8 into under root is how much? Root 2 into 10 raised to 3. Because GME by RE under root is how much you know? Already 8 into 10 raised to 3 we know. And root 2 is there, that root 2 extra written here. 8 root 2 into 10 raised to 3 meter per second. But for board, up here if you solve now, they won't give you marks. You have to extend a little more. So what does that means? So VE equal to under root GME by RE. Na? So we know that small g equal to what we know here? Small g equal to, we know that small g equal to GM by R square we know. So GR square equal to what we can write it? GM we can write it. We are going to substitute that thing in this. So VE equal to under root of 2G GR square divided by RE. In the place of GM, I'm going to substitute GR square. 1R will get cancelled. That equal to under root 2 GRE. G value is how much? 10 meter per second square, sir. RG value is how much? RE equal to 6,400 kilometers, sir. If you substitute these both values now, VE equal to how much will get it? VE equal to 11.2 kilometers per second. Means if you project any object from 11.2 kilometers per second, it will escape from the Earth's surface without getting influenced by gravitation. So we need to give a relation between escape velocity and orbital velocity. This is there in NCERT. You have to remember this thing. Up to here we have to do for boards also. Either it will be PU or it will be CBSE. or any state boards. So what we're having here, VE equal to what we got it under root 2G RE, and we already learned V naught equal to under root GRE. We learned this. So VE equal to under root 2 times the V naught, we can write it. Therefore, VE by V naught equal to what we get it, root 2 is to 1. So this is also many times CET and other boards they ask you. A ratio of escape velocity to the orbital velocity, what we got it, root 2 is to 1, which will get it here. This is also important formula which we have to understand here. In these two special cases, we have to discuss very important cases. What is the case 1 means? Case 1. What is that case means? When given speed is greater than V escape speed, then what will happen? We need to discuss here. So this question 2 times repeated in AIMS. JEE 1 time they given, and it's their standard NCERT question. It's their NCERT. So if given speed is more than escape speed, what will happen? Means it will enter into interstellar space. So let me take, this is Earth surface. From here to here, radius is how much? RE, which we know here. This mass is how much? M. V given is, let me take as K times the escape velocity. It can be anything, 3 times, 4 times, 5 times, whatever the times. And this is the final case which we are going to study here. This is RE. It's going to somewhere here, let us assume. After reaching interstellar space, earlier we taken that the velocity is 0. Now velocity is not 0. Some velocity is there. V interstellar. Space. This distance is how much? Infinity, which we can take here. So again, what we are going to apply means law of conservation of mechanical energy. We are going to apply. So total energy at 1 means potential energy plus kinetic energy. So what is potential energy? Half mv square. V value is how much? This much, Nana. K square VE square minus GME divided by RE, capital RE, is equal to half m. At final place, velocity is how much we choose in? Not 0, V square minus GME divided by infinity plus RE will be infinity. Anything upon infinity will become 0 here. So if you observe carefully here, in this term small m, in this term small m, in this term small m is there. This is capital M, right? This is small m, right? So small m, small m, small m, we can take common, we can cancel this fellow. So what we can write here means, we can write like K square V square, so minus 2GME RE, I'm multiplying with 2. Multiply with 2, multiply with 2, multiply with 2 also here is equal to what will get it? V square will get it. So K square VE square minus 2GME by RE, you will get like VE square, Nana. So there where I told you VE equal to what we got? Under root 2GME by RE. Keep this in bracket, will be useful. Square of this will be how much? VE square equal to 2GME by RE. So we can substitute that here. So equal to V square we having here. So in these two terms, V square is common, no? Therefore, if you take V square common, no? K square minus 1 equal to what will get, Nana? V square. Therefore, V square equal to what we got it? V square equal to VE square times the K square minus 1, which we got it. Therefore, V equal to what we will get it here? V equal to VE times the under root of K square minus 1. So K will tell you how many times. This is a standard formula which you have to remember. So by substituting this formula directly, we can solve that questions whichever they asked you. For example, they asked one question like this here. So what is the question says means? That example they're telling, given velocity V given equal to root 2 times the KE, then find a speed in interstellar space. So V given equal to root 2 times the KE, na? Root 2 times the VE, na? Escape velocity, sorry. So V given equal to K times the VE I'm comparing, which we taken. So K value equal to how much will get it? K equal to what will get it? Root 2. So K square equal to how much will get it? 2. So take this k square value, substitute here. Therefore, what we are having here, v equal to ve times the under root of k square minus 1. K value how much we got it 2 na? Therefore, v equal to under root of 2 minus 1 ve times v. Therefore, v equal to what we get it, ve. Means at interstellar space also it's not become velocity 0. How much velocity we got it? ve, which we got it here. We have to understand. See, in this, when case 2 we are having, what is that case 2 means? Case 2. If v given is less than v escape. So v given is less than v escape means it won't go to it won't escape from the Earth's surface, no? So then find h maximum they're asking. Find maximum height of the object which can travel. See, generally, so what we're having here means we're having Earth's surface, let me take here like this, whose radius is RE. This mass is how much? ME. We're having one object which is projecting mass is M. V given is less than n times the escape. So their n value should be less than 1, like 0.5, 0.3. It can be anything. It can be fraction also. So up to where it can go, up to certain height only it can reach. RE, up to here it's traveling mass. After reaching that velocity becoming 0. This height we need to calculate, Nana. H maximum. So this is only they'll ask you for commutative, they won't ask you for boards. That's why I'm skipping derivation, which will take more than 10 minutes. So I'm directly giving answer. You have to remember this answer. H equals to what we're having? N square RE divided by 1 minus n square will get it if we derive this thing. So n square RE divided by 1 minus n square, which will get it here. How to calculate the n value here means n equal to what we can write means v given divided by v escape speed we have to take. So if you take like this, you'll get the answer of what? N value. That n value you have to take and you have to substitute in where? In this equation, you'll get what? How much height it can travel or how much height it can, up to what height it can go, we can calculate here. So let me take one question here. What does that question says? Means question telling like this. If object given speed is 4 kilometers per second, find maximum height. If object given speed is 4 kilometers per second, then find maximum height. Up to what height it can go, they're asking. So what we can check here means, first we need to check n value. N equal to what we can write? Vg by Ve. Vg value how much they given? 4 kilometers per second. Means 4 into 10 raised to 3. We can write it. So 4 into 10 raised to 3 meters per second divided by escape value. Escape speed we will learn like 8 root 2 into 10 raised to 3 na? 8 root 2 into 10 raised to 3 meters per second. This fellow will get cancelled. 4 1 ja, 4 2 ja. 1 by 2 root 2 you got it. Therefore n equal to what we got it? 1 by 2 root 2. But in the formula we have to substitute n square na? So square it will become easy. So n square equal to what we can calculate? 1 by 4 into 2 will get it. Therefore n square equal to 8 we got it. Now we are going to 1 by 8, sorry. 2 4 is 8 na? So now I'm going to substitute in this equation. Therefore h equal to what we are having? N square Re divided by 1 minus n square. N square value what we are having? 1 by 8 into Re divided by 1 minus 1 by 8. If I take LCM, no? So what will get it here? 1 by 8 Re is equal to 7 by Re will get it. 8 minus 1. So sorry, 7 by 8 will get it. 8 will get cancelled. Up to what 8 it will go means Re by 7 it will go. So h equals to what will get it? Up to Re by 7 it can travel. You can substitute this Re value 6400 kilometers means 10 raised to 3 divided by 7 also. So you can calculate answer. How much will get it means answer will get like around 900 kilometers will get it here. But we have next question here. And the next question what they're asking me is they're asking like this. The escape velocity from the Earth is escape velocity from the Earth is about 11 kilometers per second, which we derived and we know this. The escape velocity from a planet having twice the radius of the Earth, twice the radius, and the same mean density. Density is same, it seems. Same mean density as that of Earth. Earth is, options they given like, option A they given 22 kilometers per second. Option B they given 11 kilometers per second. Option C they given 5.5 kilometers per second. Option D they given 15.5 kilometers per second, which they given here. See, we know that relation V equal to what we got it, under root 2GME by RE, which we know, and I told you to remember this formula. This will be very useful in solving the numericals, I told you. Fine. We know that density can be written as what generally? Mass upon volume. So mass can be written as density times the volume. You shift this fellow here. So mass equal to rho into volume is nothing but, it's almost looks like spherical thing, na? 4 by 3 pi into RE cube, which we can write it. Therefore, V equal to under root 2G, in the place of ME, I'm going to substitute rho into 4 by 3 into pi RE cube, I'm going to substitute, divided by RE. So 1 RE will get cancelled, RE square remains. So if you observe in the question, no, we need to find the ratio methods. 2 is constant, G is constant, mean density is same in the question they mentioned somewhere here. So you can observe here, mean density is same mean density. And rho is constant, 4 by 3 is constant, pi also constant. Here how much remains? RE square. Means, observe these are all things constant. I'm taking like proportionality constant, these all things. VE is directly proportional to what we can write it here. Under root RE square, I can write it here, RE square. Square root will get cancelled. VE is directly proportional to what we can write as under root RE. So now you need to calculate the word planet, no? So if you want to write planet ratios, no? V planet to the V Earth can be, sorry, square and root cancel, no? So the square root will not come again. V is directly proportional to RE. So V planet to the V Earth can be written as what, no? R planet to the R Earth. So VP by V equal to R planet is how much they told. So radius velocity twice the planet, no? Twice, 2 RE will get it. 2 RE divided by RE. 1 RE will get cancelled, means VP equal to 2 times the VE. So VE value also they given in the question. How much is that? They given clearly 11 kilometers per second. So 2 into 11 kilometers per second. So V planet is nothing but how much will get it? 22 kilometers per second, which we can conclude our answer. This is the answer which we got it here. So basic, this is also average question, not difficult question, not even easy question. So average question, you need to learn how to convert the mass to density, which we already did while solving the derivations. Fine, yes, this is for today's class. So watch everything carefully and make your notes clearly. So thanks for watching this video.